We want to solve z cubed plus 8 is equal to 0. I'm going to start by looking for a linear factor of the left-hand side using the factor theorem. But note, this isn't the only approach to this, and we'll look at a separate approach towards the end of the video. So, with the 8 here, we only really need to worry about plus or minus 1, 2, 4, and 8. So we'll let f of z be equal to z cubed plus 8. And you shouldn't have to look too far to see that f of negative 2 is going to be negative 8 plus 8, which is 0. And so z plus 2 is a factor. So z cubed plus 8 would be equal to z plus 2 multiplied by some quadratic factor. To get z cubed at this end, we need to start with z squared. To get plus 8 at this end, we'd need to finish with plus 4. We don't know what goes in the middle, so we'll just for now call it az. If we look for coefficients of z squared, on the left-hand side there are no z squared, so the coefficient is 0. What gives us a z squared over here? We're going to get 2 from there, and we're going to get a from there, which tells me that a is negative 2. So I have z plus 2, z squared minus 2z plus 4 is equal to 0. Clearly, z equals negative 2 is one of the solutions. The other solution is going to come, or the other solutions are going to come from z squared minus 2z plus 4 is equal to 0. Let's use the quadratic formula. Z would be 2 plus or minus the square root of negative 2 squared. Take away 4 times 1 times 4, all divided by 2 times 1. So that's 2 plus or minus the square root of 4 take away 16 over 2, which is 2 plus or minus the square root of negative 12 on 2. So, now if we think about 12, 12 is 4 times 3, so root 12 is root 4 times 3, root 4, root 3, which is 2 root 3. So that's 2 plus or minus 2 root 3i divided by 2, giving us 1 plus or minus I root 3. Note, once again, we started with an equation with real coefficients, and the complex roots are a conjugate pair. For this particular equation, I think we could have got there in a slightly easier fashion. So we had z cubed plus 8 is equal to 0, which is z cubed is equal to negative 8. So z cubed would be equal to 8 cis pi plus 2n pi, where n is an integer. And so z would have been the cube root of 8, which is 2, cis pi by 3 plus 2n pi by 3. And so we could have tried n equals 0, which would be 2 cis pi by 3. N equals 1, which would be 2 cis pi. And n equals negative 1, which would have been 2 cis negative pi by 3. So, cis pi is just negative 1, so this one is negative 2. This will be 2 cos pi by 3 plus 2i sine pi by 3. And that would give me cos pi by 3 being a half, 1. Sin pi by 3 is root 3 over 2. So that would have given me plus I root 3, which is one of the solutions we had up here. And the other one over here would be 2 cos negative pi by 3 plus 2i sine negative pi by 3. Now cos of negative pi by 3 is a half, so that still gives me 1. Sine negative pi by 3 is negative root 3 over 2, so that gives negative I root 3. Once again, note complex ones are a conjugate pair, and they are the same as what we found earlier.